Welcome to our quick review of population statistics, and it is going to be a very quick review. This show only has two slides other than the one you're looking at here. So really quickly, when we're talking about population increases and decreases, we're looking at things like crude birth rates, crude death rates, total fertility rates, rates of natural increase, also immigration, emigration, and finally, the demographic equation. So it's a long list. Let's go ahead and start at the top. Crude birth rates are the number of babies being born per 1,000 people in a given population. Crude death rates, similarly defined, only now instead of births, it's deaths. Okay, total fertility rates are a little bit different. And the way that total fertility rates are different is that really they're a prediction. How many children will the average woman have during her reproductive years? And for reproductive years, figure basically these days probably about 14 to 40. Okay. And that's just an eyeball estimate, and it'll vary obviously individual to individual, but it's different than how many babies are actually being born, which is what the crude birth rate measures. Um, total fertility rate again is just really an estimate more than anything else. The rate of natural increase, on the other hand, this one is really easy. It's basically a math equation. Okay, so rate of natural increase equals crude birth rates minus crude death rates. And the way I want you to remember this or think about this is think about it as if a population were completely isolated from all other populations, so nobody could get to it. What's the rate at which it would increase? That is the rate of natural increase. Okay, and then we've got immigration, which is people coming into a country. Okay, emigration is people leaving a country. So all immigrants are emigrants, and all emigrants are immigrants. It's just at what stage of their journey they're at. And last but not least, when we're talking about population statistics, is this thing called the demographic equation. And it sounds super fancy schmancy, but it's really not. Um, it's just a mathematical equation to predict the rate at which a population is growing, or at least to estimate it, since obviously some of these things are harder to get numbers for than others. And the demographic equation goes like this. You take the rate of natural increase, okay, so that's the birth rates minus the death rates, and then you add the number of immigrants, people coming into the country, you subtract the number of emigrants, people leaving the country, and that will give you what the population change is over a given period of time. Okay, so it really is all about just how are we talking about population change. That's what every one of these is about. The other thing you need to talk about when you're talking about population statistics are population composition. And the reality is you can create statistics regarding any statistic you can think of or any trait you can think of in a given population. All right, so in a ninth grade classroom, I could have all of the girls stand up. Well, that's a gender ratio, right? All of the girls compared to the boys. I could have all of the 14-year-olds sit down and everybody else stand up. And now I've got an age ratio, 14-year-olds to 13, 15, and 16-year-olds. Right? I could have everybody with brown hair stand up, or everybody who's got a certain reading level, or whose parents are engaged in a certain field, or who who felt like who were really excited to take the class, or people who were dreading the next test. Okay, those are all things that the population is composed of. The most important things that geographers tend to talk about, though, are gender ratios, age ratios, and along with age ratios is this idea of a dependency ratio. Okay, and the dependency ratio, basically what you're doing is taking all of the people who were too old to work and all of the people who were too young to work, and we're comparing it to the number of people who were actually of working age. And working age, generally speaking, is defined as being from age 16 up to age 64. Okay, and so if you have a high dependency ratio, in other words, you've got lots and lots of people who are not able to support themselves, that are not working, to compared to people who are able to support themselves and able to help those other people out, that's got a lot of possible implications for your community. So if it's a young dependency ratio, in other words, you've got lots of kids, now you're looking at you've got to spend more money on education, you've got to spend more money on things like vaccination programs. Okay, that's very different than if you've got an elderly dependency ratio where you've got more old people, and so now you're focusing more on healthcare for chronic conditions. Um, you're looking at needing a different type of full-time care, maybe potentially more acute care, right? You need to make sure that you're able to pay pensions and things like that. So having your dependency ratio skew one way or the other can be a real problem in terms of helping a community to be self-supporting. Gender ratios can be similarly problematic. In general, if a population is left alone, there's roughly somewhere between 101 to 104 girls who were born for every 100 boys. So it's basically even numbers. Basically even numbers. If you tweak with those numbers, that becomes a problem. In particular, if you get rid of girls. And what's really interesting to see is there's some countries where this has happened, particularly with more modern medical technology and the ability to tell the gender of a fetus before it's been born, which you have, and this is a big issue in China, it's also been an issue in India, what's called sex selective abortion, where parents will abort female fetuses and then try again in the hopes of getting a male fetus and ultimately a male child. And what you see is, and I think the last numbers I saw for India and China were something like 130 males for every female, or for every 100 females, sorry. Um, and this is a big problem. First of all, because that means that you've got a whole bunch of young men running around with very little tie to the community. Okay, they're not settled down, they're not raising a family. Okay, and young men who have a stake in the outcome of the community are a lot less likely to go out and do things like stage revolutions. They are less violent. Um, they get involved in fewer hijinks. So that becomes a real issue. And even when those numbers are even just a little bit off, say it's um, uh, say roughly 98 girls for every 100 boys. The trick is girls tend to marry slightly older men. And so even if that ratio is close, it's still entirely possible to have a skewed ratio in terms of young men who are unmarried and thus again not tied to the success of the community as a whole. And this becomes can be a huge issue. You know, another area where this has happened, where we've got large pots of unemployed young men who can't settle down because they can't afford a wife or a family, is in the Middle East. And so if you've heard anything at all about the Arab Spring, a lot of those protesters, most of them, in fact, in those various countries, were young men. Um, and so it was young men who were staging the sit-ins, who were um, fighting and clashing with the military, so who were overthrowing governments, in essence. When you look at who's most likely to go off and join a terrorist group, and I hate to say it, guys, but overwhelmingly young men who were unwed, And by young, I mean late teens, early 20s, with fewer ties to the community, are statistically significantly more likely to go off and go join an extremist group like that. And that's not to say that all young men are going to do that, and it's not to say that you're going to do that, you as an individual. Just know that, or that girls don't do that. Just know that it's more likely to do that, and that gets into realm of psychology and things like that. And if you ever are curious about that, I'd be delighted to have that whole conversation with you. This is really the end of our discussion about population statistics. As it turns out, this lecture was a little longer than I expected, but that's okay. If you have questions about any of these ideas, please, please, please feel free to come see me in class, and I'd be delighted to explain them to you in a little more depth.